Hello and welcome to today's lecture from Brit University. Hi, I'm Nick.
And I'm Jane.
Today we're going to look at momentum and how we can use this to understand why we need crumple zones in our cars. Let's start off by looking at some theory on the whiteboard. Let's remind ourselves that momentum is equal to mass times velocity. If our car weighs 1,000 kilograms and it is travelling at 25 meters per second, what is its momentum? That's right, you've got it. 25,000 kilograms meters per second. What happens when a car hits a wall? Because the car's velocity becomes zero, its momentum must change to zero during the collision. We can use the change of momentum formula to allow us to find the force that acts on the driver during the collision. Rearranging the formula, we get force is equal to change of momentum divided by the time over which the collision acts. Now we can use this formula to see how we can reduce the force on the driver. Because the change of momentum will be the same for any specific collision, if we increase the time, it will make the force smaller. Now we can put this theory into practice by looking at crumple zones in a real collision. Let's go over to our brave stunt driver Ollie. Ollie, are you ready to go?
I think so.
Oh dear, I hope Ollie was okay after that second crash. Now let's go back to the whiteboard to see if we can work out the forces involved in those two collisions. So the car had a mass of 500 kilograms and a velocity of 10 meters per second. In the first collision, when the car had a crumple zone, the car and the wall were in contact for 1 second. So if we put those numbers into the formula, we can see we get a force of 5,000 newtons. Now let's look at the second collision. In this one, the car had no crumple zone. So the car had the same change of momentum, because it was still 500 kilograms, going at a velocity of 10 meters per second, but the contact time between the wall and the car was only 0.2 seconds. So if we put these numbers into the formula, this time we get a force that's much greater of 25,000 newtons, which is why poor old Ollie ended up being thrown out of his seat. You'll be pleased to know that Ollie has made a full recovery and will be ready to do some more experiments for us next week.
That's all for this edition, so it's goodbye from me.
And goodbye from me.